6.9 Molecular Formula. A compound's molar mass based on the molecular formula is always a whole number multiple of the molar mass of the empirical formula. You can find this multiple x by dividing the molar mass of the compound by the molar mass of the empirical formula. Let's try a sample problem, finding a molecular formula given its empirical formula. Find a molecular formula given its empirical formula. Determine the molecular formula of a compound with empirical formula CH2 and molar mass 84.18 grams per mole. Step 1. Find the empirical molar mass by adding the molar mass of each of the elements. So the molar mass of CH2 is equal to the molar mass of carbon plus 2 times the molar mass of hydrogen, because there are 2 hydrogen atoms in the empirical formula. So that's 12.01 grams per mole plus 2 times 1.01 grams per mole. And the molar mass of CH2 is 14.03 grams per mole. To solve for x, we need to have the molar mass of the compound divided by the molar mass of the empirical formula. So x equals molar mass of compound divided by molar mass of empirical formula. So the molar mass of the compound is 84.18 grams per mole. That was given to us in the question. And we just found the molar mass of the empirical formula, 14.03 grams per mole. So x equals 6.00. So we're going to multiply everything in the empirical formula by 6. So this becomes C6H12. So again, we multiply each of the atoms by x, which is 6. And we end up with the molecular formula for the compound, C6H12. Let's use percentage composition. Sample problem number 2. Using percentage composition data, determine the molecular formula of vitamin C, ascorbic acid. This compound contains 40.5% carbon, 4.6% hydrogen, and 54.5% oxygen. Its molar mass is 176.14 grams per mole. In step 1, we're going to determine the amount of each element in a 100 gram sample. So we need to find the number of moles of carbon, which is equal to the mass of carbon divided by the molar mass of carbon. In a 100 gram sample, 40.5% carbon would be 40.5 grams of carbon divided by the molar mass of carbon, 12.01 grams per mole. And we end up with 3.372 moles of carbon. Let's do the same for hydrogen. It's the mass of hydrogen divided by the molar mass of hydrogen. So that is 4.6 grams. That's the amount that 4.6% of 100 grams would be, divided by 1.01 grams per mole, the molar mass of hydrogen. If we punch this in, we get 4.555. Let's do the same for oxygen. The number of moles, or the amount of oxygen, is the mass of oxygen divided by the molar mass of oxygen. So 54.5% becomes 54.5 grams out of 100 grams, divided by 16.00 grams per mole. And we end up with 3.4063 moles of oxygen. So a 100-gram sample contains 3.37 moles of carbon, 4.55 moles of hydrogen, and 3.41 moles of oxygen. Next, to determine the simplest ratio, divide the amount of each element by the smallest amount. So we have 3.372, 4.555, and 3.406. These are all moles. And we're going to divide each of these amounts by the smallest amount. In this case, the smallest amount is 3.372. 3.372. 3.372. If we divide them all by 3.372, we get 1 for carbon, 1.01 for hydrogen, let's try this again. 4.555 divided by 3.372, we get 1.35. And for oxygen, we get 1.01. So this gives us the empirical formula C1H1.3501. If we multiply each of these by 3, we end up with C3H4O3. So the empirical formula is C3H4O3. And if we want to go from the empirical formula to the molecular formula, we're going to need to first determine the molecular mass of the empirical formula. The molecular mass of C3H4O3 is 3 times the molar mass of carbon, plus 4 times the molar mass of hydrogen, plus 3 times the molar mass of oxygen. So that's 3 times 12.01 grams per mole, plus 4 times 1.01 grams per mole, plus 3 times 16.00 grams per mole. And the molar mass of C3H4O3 is 88.07 grams per mole. Now let's solve for the mass multiple X. It's equal to the molar mass of the compound divided by the molar mass of the empirical formula that we just calculated. The molar mass of the compound, let me go back and see what it was in our question, so I seem to forget it. The molar mass is 176.14. And the molar mass of the empirical formula is 88.07 grams per mole. If we punch this in, the mass multiplier is 2.0. So the molar mass of the compound is twice the molar mass of the empirical formula. So we'll multiply each by 2. So multiply the empirical formula by 2. And we end up with C6H8O6. So the molecular formula for the compound is C6H8O6. Please read over this section, try any practice problems assigned, as well as any LMS quizzes. Good luck.